In this example, we have four systems of linear equations, and you can verify that in A, B, C, and D, these systems have already been put into triangular form. So that's a good thing to review and check that the conditions are satisfied for triangular form. And now that they're in triangular form, let's identify whether the system is consistent or inconsistent. And if it is consistent, let's find the solutions. So a system is going to be inconsistent if there are no solutions. And the way that we can identify once system has been put into triangular form that it's inconsistent is, for example, in question C, we can see over here we have a contradiction. Okay, certainly minus 5 is not equal to 20. This is not true, and there's no values of x, y, and z that I can substitute to make that true. So when we have a contradiction like that, this tells us that the system has no solutions. And that we call inconsistent. And to just be careful, in part A, you might think that seems like it looks pretty similar to C. So in part A, we have 2 equals 2. So that last equation doesn't have any variables, but that is a true statement. So no matter what I use for x, y, and z, that last equation is going to hold. And looking at the rest of this system, we can see that there is no equation that has z as the leading variable. So we say in this case that z is free in system A, and therefore we can parameterize it with t. So plugging this in to the second equation would give us that y minus 3t is equal to minus 9. I'm just plugging in t in place of z in equation 2. So that tells me that once I choose a value for z, that's going to determine what value I should choose for y. Namely, y is going to be minus 9 plus 3t. And similarly, plugging these conditions into the first equation in system A would give me that x plus 5, and now replace z with t, is equal to 8. And so this tells me that x is equal to 8 minus 5t. So we have solutions of the form x, y, z is equal to 8 minus 5t minus 9 plus 3t, and z is equal to t. And since we have a solution, we have many solutions, we say that part A, this is consistent. And since we have a free variable, that means we have infinitely many solutions. We say that this is dependent. So part A is a consistent dependent system. And part D has a similar structure in that the last equation doesn't have any variables in it, but it's true that 0 equals 0. So in this case, we see that y is free. So we can parameterize y with t. We see that z has to be minus 8. That comes from equation 2. So this we can use to figure out what x needs to be. So x needs to satisfy the equation that x minus y, and now I'm going to replace y with t plus 2 times z, which I replace with minus 8, equals 12. So solving this for x, we get that x is equal to 28 plus t. So y is free, z is equal to minus 8, and that gives x is equal to 28 plus t. So our solution here is xyz is equal to 28 plus t. Y is equal to t, it is free, and z is minus 8. So there's our solution for this system. Since it has a solution, system D is consistent, and since there are infinitely many, this is dependent. And that leaves the last system in B. And in part B, none of the variables are free. So I see from the last equation that solutions must have z is equal to 2. And so I can plug that into equation 2 to get the value for y. So this means y should equal 3. Y minus 3 times 2 needs to equal 0. So that tells me that y equals 6. And then I plug those values into the first equation, which is x plus 13y that I now substitute with 6 is equal to 6. And so solving that for x gives us x is equal to minus 72. So therefore my solutions are x, y, z is equal to minus 72, 6, and 2. There's only one unique solution, so this is a consistent independent system. So to summarize, when systems have solutions, we call them consistent. And there might be just one unique solution, in which case it's consistent independent, like in part B, or we may have a free variable, like in parts A and D, in which case we have infinitely many solutions, and then we call the consistent system dependent. And if we have one of our equations, once we put it into triangular form, is some contradiction that looks like the last equation in C, that's simply not true. This means that the system has no solution and we call it inconsistent.